live now.
Not seeing it yet, but this was a delay.
Should be live now.
Oops. You know what? I need to turn off the YouTube. Okay. That was the delay there was because I actually also had the YouTube thing open. You still there, Elric?
Yep, I'm still here.
Okay.
All right.
We're about to like laugh about regulation. So.
All right, so we are here for another Friday Lunch and Learn at the front side. Hold on 1 second here. Yep, and today we're going to be talking about Kubernetes for the Kubernewbie from a DevSigner's perspective. So why make this talk? This talk is for people that were like me at one point in time, that, you know, people that really didn't know any Kubernetes. Coming into DevOps and systems administration and Kubernetes and all these things coming from a DevSigner's perspective was a challenge. So if you happen to be like one of these people here, you might be good. You might already know Kubernetes and DevOps very well. But if you're like someone that doesn't have much exposure to DevOps and system administration and things of that nature, you don't work with those things day to day, you may need a kickstart, and hopefully that this presentation will get you running down the road. Once again, you know, I didn't really have much experience with DevOps or system administration. I have more experience with these various things here: UI and design, front-end development, mobile development, back-end development, but really not much ops. But when you're building applications nowadays, there's a lot of things that come together. There's a lot of moving parts that come together to make a successful application. And you could easily find yourself in the land of DevOps and wondering, how did I end up here? So no problem. You know, we can just be fearless, just jump right in and just start learning. Back in the day, Mark Zuckerberg said, move fast and break things. And he got a lot of heat from everybody for saying that statement. But I took it a little differently when he initially said that. But the rest of the world was just like, oh, this guy is crazy. So I'm going to adapt that a little bit today and say, move fast, make things and break them, but don't break them in production. You know, make throwaway apps, make some prototypes, whatever you got to do, but give yourself some sort of sandbox environment that you can just mess it up and you just don't really care. You can just experiment as much as you like. So I'm thinking like Kubernetes, this is going to be easy. Like, you know, I've like deployed apps before and things, so, you know, but that's what I thought. And it turns out, you know, had to pump the brakes a little bit once I hopped in there because it was just so much to learn. So, you know, when you're working in a particular part of the stack and you're working there for a little while, you start to build a lot of domain-specific knowledge and you start to grow into that particular area. So you think that just, oh, I can just jump over to another place, I'm good. But in all actuality, this is how you really are when you go into a new domain or you're new coming into a specific area. Yeah, a little small minion there in the middle, and that big circle around you is all the domain-specific knowledge that you have to figure out. So today, we're going to hope to build some domain-specific knowledge around DevOps and Kubernetes. And they call it K8S, so if you ever hear someone say K8S, they're talking about Kubernetes. And it's actually because there's 8 letters in between the K and the S. And I figured that out, and I was like, oh, that makes perfect sense. Okay, so Kubernetes. Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. That is the first thing I read when I looked at Kubernetes, and I was like, you know, bruh. Like, and I'm sure other people that reading that are probably like, I thought you said you were going to help newcomers. Like, what's going on here? But no worries. So a little more about Kubernetes. It builds upon 15 years of experience running production workloads at Google. So it was influenced by some internal systems that Google has. I don't know if they still have these things in place. I'm not sure. Borg and Omega, but Kubernetes was influenced, and it's like maybe the third iteration. So it was influenced by some internal systems that Google has. I don't know if they still have these things in place. I'm not sure. Org and Omega, but Kubernetes was influenced, and it's like maybe the third iteration. So influenced by some internal systems that Google has. I don't know if they still have these. I'm not sure. Org and Omega, but Kubernetes was influenced.
I know, like you could click there.
Yep. All right, cool. We're back on track. Yeah, so I don't know if they still have these in place, but Kubernetes is like the third iteration on top of that. So Google has a lot of experience with containerized applications, and as the world started using containers and microservices and things like that, Kubernetes strives to give everyone that same production level solution that Google has. Google probably spins up billions of containers per month. Who knows the number? It's probably an astronomical number. So a containerized application. That sounds a little strange. So we can just say for now that it's an application that's within a container. And you're like, well, okay, well, what's in container? So this is like the Webster's dictionary, I believe. Definition of a container is an object that can be used to hold or transport something. Now, in tech speak or DevOps, that something is everything that a software needs to run. So it's the application code, configuration, and dependencies that's inside that container, that you hold inside that container. So the tech definition of a container is an abstraction, operation system level virtualization that allow you to run application and its dependencies in a resource isolated process. So operating system level virtualization is also known as containerization. It refers to the operating system feature in which the kernel allows the existence of multiple isolated instances. And those instances are the containers. And those containers share like one host across them. There is a difference between this and virtual machines, but I just sidestepped that to just keep talking about containers. So this is a image of what a container will look like when it's in this environment. And all in all, we can then say that a container is a containerized object that is an isolated resource that is used to transport everything an application needs to run. So hopefully that's like pretty straightforward and a good definition. So to create a container, you need a container image, right? And you can use something like a Docker file to create that image. So over on the part that says a Docker file, that's like just a made up Docker file, but this is potentially what your Docker file will look like. And from that Docker file, it's like a template that you will use to then build an image. And as you see, the image is built from the bottom up. So it's kind of like layers. So the first part where it says from Python Alpine, that's like your base layer. And then you start to go and start to install the packages and everything, libraries, whatever you may need, your application code, and you start to build on top of that. And that is what you use to then, in turn, build a container. Right? So then once you have those images, you can either have those images locally on your machine, you can push them up to Docker Hub, Google Container Registry for your own use, for public use, whatever the case may be. And then you can pull those images down to then use those to build your containers. So you're probably thinking like, wow, that's a lot of fancy talk, but is this Kubernetes yet? But we have to build that baseline because Kubernetes is based on using containers. So now that you have the power to just make a bunch of containers, how are you going to manage these things? And that's where Kubernetes comes into play. So Kubernetes, so how does Kubernetes help you with automating the deployment, scaling, and management of all these containers? This Kubernetes is also known as orchestration software to help you like manage all of these, however many containers you end up having inside one of your clusters. So Kubernetes has a lot of concepts and features, and it's a very powerful system. But today, I'm going to try to scope it down and only talk about pods, deployments, and services. I think that with these three things here and understanding of these three things, that then you can start to branch out and dig deeper into all of the various parts that Kubernetes has. So what's a pod? A pod is the smallest deployable unit in Kubernetes. It can contain one or more containers and volumes. And as you can see from those two pictures, we got a X-Wing pod that has like one container and a TIE Fighter pod that has two containers. So in a pod provides execution context and isolation for the containers. So two containers that are running in the same pod has the same context, they have the same IP address, and they can communicate with one another using just native inter-process communication to one another. And in addition to that, like containers that are on the same pod or within the same pod are guaranteed to land on the same machine when you deploy them. So that's another thing that pods provide you. So containers that happen to be in different pods, because pods provide a level of isolation, you can think of those two pods as just being on two separate servers. So the means of communicating between those two pods, you're going to have to use some different techniques to communicate between those two pods. So I said we were only going to talk about pods, deployment, services, but then somehow or the other, the volume snuck in here. So what's a volume? A volume is a way to persist data and share data between two containers on a pod. Volumes are also needed because when a pod crashes, it loses all its data and it just starts fresh, right? So like a pod will crash, or it could crash, and the container, you could be writing dynamically writing data to the disk in the container, and then if it crashes, it just starts back fresh like you just deployed it. So using a volume is a way to preserve information in between crashes. So the volumes are mounted into the pod, and there's a lot of different volumes that Kubernetes supports. It's like the list is really, really long, and there's different ways that you can persist data. But the gist of it is that the pods are mounted, the volumes are mounted into the pod. So if a pod crashes, the volume is unmounted. As you see over in pod 1, oh, oops, it crashed. It unmounts that volume, and then when the pod comes back up, it just remounts the volume, and then there's all your data. So when the pod comes back up, automatically you're like, what? Like, you know, you would think that you would have to go in and do it manually, but Kubernetes is here to help you out. It's self-healing in a sense. So when pods are backed by something called a replica set in Kubernetes, that replica set will keep your pods running at the number that you specify. So if you want 3 instances of a pod, of this X-Wing pod running, and one of them just happens to crash, Kubernetes will go and then say, hey, this person said they wanted 3 X-Wing pods. Now there's only 2. Oh, let me just spin up another one for you. And there you go, you're back to 3. And you're like, whoa, like this is crazy. Okay, so how do we get some pods? There's a few ways that you can create pods in Kubernetes, but today we're going to talk about going the route of using something called a deployment, right? So deployment in Kubernetes, I was trying to find a good way to explain this. So, but it's a way of creating pods and replica sets like at the same time together and manage those elements, right? And a pod, using a deployment, it also unlocks rolling updates to pods. So if you update something, or you want to update something in some pods, you can do like a rolling update to those pods, right? So in Kubernetes, Kubernetes is a declarative system, and it uses YAML files to express to Kubernetes like how you want your system to look, how you want your deployment to look, whatever you're creating. You use a YAML file to then create that specific thing within Kubernetes. So let's look at a deployment here. So this is what a deployment would look like in Kubernetes. This is the YAML file here. So at the upper part, this is specifying the API that to Kubernetes, what API to use. The second part there is the resource type. There's a lot of different resource types in Kubernetes. A pod is a resource type, a service is a resource type, deployment's a resource type, replica set's a resource type. They got a bunch of them, replication controllers. They can go on. The list is really long, but we're just talking about deployments here. So if you go down, you see where it says replicas. We're just creating one pod here, and then the Kubernetes uses labels to find things within the cluster. So here it's saying like, okay, you're going to create some pods. You're going to label them X-Wing, and when its deployment is pushed, it's going to create these pods. It's going to give them the label X-Wing. And then down at the bottom here, we're just saying like what container image to use. So that container image could be pulled from anywhere. So to create a deployment, you would need some sort of environment that's running Kubernetes. So you can use Kubernetes has a local development environment that you can run within this thing called Minikube, or you can then go and get like a account on Google Container Engine. As of right now, if you sign up for just a regular non-business account, I believe. I think they might do with business accounts. But if you sign up with a new account on Google Container Engine, you can get $300 credit, and you can go on there and play around with Kubernetes and build stuff until your $300 credit runs out, and then you can either just keep paying or then just use Minikube. But using Minikube doesn't have all the feature sets as something like a Google Container Engine or AWS. So bear that in mind. It may not have everything. You also need something called kubectl. Kubectl is a command line interface that's used for executing commands against your Kubernetes environment. So once you have an environment running and kubectl, this is the command that you would run to then apply or create that deployment that we were just looking at and create it within Kubernetes. So this command here means to apply, the dash s means a file, and it's going to apply, it's going to use that file to then create that deployment. So the deployment is going to be created, replica set is going to be created, and the pod that you want is going to be created, right? So the deployment manages the replica set. The replica sets manage the pods. That's how it goes in Kubernetes. So when you create a deployment, it creates a replica set, and as we spoke about earlier, when a pod crashes, it's the replica set that then says, oh, wait a minute, there's supposed to be X amount of number of these pods. Let me go and create whatever this person specified. So we can go in and then say, all right, well, let's change it's running, we have our deployment, we have everything running, and we want to change and scale up our deployment. We can run this command here, kubectl edit, and then you want to edit a deployment, and that should say X-Wing deployment, and it's going to pull up the YAML file for it. So we scaled it up to 3, and what's going to happen now is that Kubernetes is going to say, oh, wait a minute. Okay, they scaled up the application. The replica set is going to go in and it's going to create 3 X-Wing pods for us. So if we want to edit our YAML again, you can be doing some sort of like continuous integration or something of that nature, but we're just going to manually do it here. We go in and we update the image. So we want to get a faster X-Wing now because the 1.0 is too slow. We're going to go up to 2.0. So we change the image to say 2.0. And what's going to happen there is that Kubernetes is now going to trigger a rolling update. It sees that, okay, these first X-Wing pods had a 1.0 image in there. Let me go through and one by one update the pod with the new image and then give this person a new image, new pods running with that 2.0 container image running. So you're like, what? This is great, you know? 50x. We're not saying 10x anymore. It's 50x. So that's awesome. So we were almost there. We're going to talk about the last thing on the list. We're going to talk about services. So a service is a way to create like an access point to those pods. So you have all these pods running, and you need a way to communicate with those pods through like a central point. That's what a service gives you. So a service can be used for internal communication, or it can be used to give you external address to then give you access into your cluster. So as we learned earlier, a pod can change. It can crash, it can scale up, it can scale down, and there's like no guarantee that the IP address for those pods are going to be the same. What a service provides you is it allows you an access point to those pods that will not change, and regardless if those pods behind the service change, it doesn't matter. Like it will just still you will still be able to communicate with those pods behind that service. So here's another YAML file. As we said, you know, Kubernetes is a declarative system. We want to create a service, so let's create a YAML file. So again, we're telling Kubernetes the API to use. The resource type is a service again, and then we're defining some ports, and then we're giving it the label, because when the service is created, it's going to Kubernetes uses labels to find things. So it's going to know that, like, hey, this service that I'm creating here is going to be backing those X-Wing pods, because those pods had matching labels of X-Wing, and then it's going to create an X-Wing, create a service that's going to back those X-Wing pods. And then down on the bottom, this is the service type. There's 3 different service types, but here we're creating a node port. So again, you go and you use your kubectl command line, and you apply that service, and it's going to go and create that service. So now we have a X-Wing service. So that X-Wing service, as you see here, is backing those 3 X-Wing pods that we created. So if something wants to communicate to those pods, it can then go through the service, and then if any of those pods change, it doesn't matter. You can still communicate because you're going through that service. So now we want to get, like, you can use the service to create external communication into the cluster. So this is the same YAML file that we had before, but at the bottom, rather than saying node port, we define a load balancer. So then what a load balancer is going to do, or that definition is going in different places, it may be called different, but it's going to create an external load balancer. So what that's going to give you is going to give you an external IP address that you can then access from anywhere on the web. And then again, it's going to come in, it's going to hit that service. That service is going to be then backing those X-Wing pods, and the same thing as before, but now it's an external address. And that's about it. Like, we covered a whole bunch of stuff today, but that's like barely scratching the surface of what Kubernetes can do, of all the features in Kubernetes. But with these 3 things, you can go and get something up, get something running, and start building out your knowledge from there. This book right here is a book that I wish I had when I first started messing around and learning Kubernetes. It's a really good book. And so if you're going to then go from here and want to learn some more stuff, dive a little deeper, this will be a good place to then start. So that's it. We did some Kubernetes, and yeah, so get out there and do some more. Yep. And that's all for today. Deuces from the front side, and and I hope you enjoyed it.
All right. Anybody got any questions for Art? I actually had a couple, but I lost them.
I'm disappointed that he a Star Wars like context for everything, but didn't use pod racers. Come on.
Right. Next one. Kubernetes for the Kubernetes part 2.
But
we'll put those in there.
Like they'd be crashing all the time.
Yeah. Cool.
That's the only Star Wars I've ever seen.
Episode 1?
What?
What?
You know, like 98.